In this video, we're going to work through some problems where we're going to combine some functions. In the first example, we're going to do some basic operations with the functions, and it's going to be subtraction. So I have the first example here on the screen. We're asked to compute f minus h of 4. Okay, so I have the function declarations here on the right-hand side over here. So in this particular problem, we're going to be working with function f and function h. So that's going to be this one right here and this one. Okay, so what we're going to do is when we're looking at these functions, let's look at function f first. Okay, so f of x is 5x minus 3. So what we're going to do is anywhere we see an x in that function, we're going to replace it with the number 4. Okay, so this first one for f of x, we have 5, and then x is going to be a 4 minus 3, which is going to be 20 minus 3, which is 17. And then for h, we have 3 plus, and then again we're going to replace x with 4, and that's going to be divided by 7. So we have 7 for the numerator, 7 for the denominator. 7 divided by 7 is 1. Okay, so what we have to do now is we're going to subtract h from f. Okay, so we know that f, our result was 17, and h, our result was 1. So this is saying f of 4 minus h of 4 is going to be 16. Now we could have done this all at once, and I'll show you what I mean. Let's erase this right here, and let me show you what I'm talking about. Okay. We could have just written it all out all at once. So it would be f is going to be, so it's going to be 5, and then we're replacing x with 4, minus 3. Okay, that's our first function. And we're going to subtract the function of h. So it's 3 plus, and then we have an x again, so we need to put a 4 over 7. So order of operations, do groupings, and so we'll just do this first grouping on the left first. So we have 5 times 4 is 20 minus 3, and then we'll leave this, we'll keep going on this first grouping, but I want to just keep this all together over here. Okay, so 20 minus 3 is 17. So now we'll work on our next group, and it's a fraction. Numerator is going to be first, so that's going to be a 7, and then denominator, and so that ultimately is a 1. So we have 17 minus 1 is 16. So either way you want to do this is perfectly fine. Okay, so that is our first problem. Okay, here's our next problem. They want us to evaluate the following composition, and this composition is the composition of f and g of x. It's important to remember that a composition of functions, it's simply just one function followed by another function. Okay, so we have here f and g of x, and what we need to do is the function f is applied to g of x. Okay, so the function closest to the variable x is going to be applied first. Okay, so here we're dealing with this first function and this second function here. Okay, so writing this, it's basically going to be the function of x, and then we're going to replace x with g of x. Okay. So now let's go ahead and replace these with their actual equations here. So f is going to be 5, okay, and then where there's the x, we're going to replace that with g of x. Okay, so I'm going to just put an empty parenthesis right now. So now I'm going to fill the x. Okay, remember f of x, we're just going to replace that x with g of x. And so that's going to be x to the second power plus 2. Okay, so now the first step is to distribute the 5. So we have 5x squared plus 10, because 5 times 2 is 10, and then minus 3. This becomes 5x squared plus 7. And that's as far as we can go. So this is our answer right here. This is f and g of x, okay, is 5x squared plus 7. All right, we have one more composition here. And this one's going to be the composition of h and g of x. So it's the same idea as the last one, okay? It's simply going to be h and then g of x on the inside. All right, so now we're working with these last two here. All right, so let's go ahead and now replace our, put our values in here. So we have 3 plus, and again, where we see x, we're going to put g of x, okay? So let's put my parenthesis, and g of x is x to the second power plus 2. So that's the numerator, and then that's all over 7. Okay, so let's go ahead and simplify the numerator. Let's get rid of the parentheses. We don't actually need the parentheses in this case. So we have common terms here. The 3 and the 2 can be combined. All of that goes over 7, and that's as far as we can go. So this is our answer for the composition of h and g of x. All right, the next problem, they want us to graph g of x. So we're going to be dealing with g of x right here in the middle. Okay, so the first thing that we need to do is we need to find some of our key points, right? We want to graph something, so we need to find the key points, so the intercepts and the vertex if there is one, or a start and end point, okay? So on this one, we know right away it's going to be a parabola because we see it's x squared. So that right there tells me it's going to be a parabola because it's part of the square family. All right, so let's go ahead and replace the g of x and just put y for that for now, since we're graphing. All right, let me get my order of operations showing here, since that's going to be relevant to this particular problem. All right. So we remember the order of operations, and I have that listed right up here, is y equals AF multiplied by x minus h and then plus k, okay? This is the form that we're going to be dealing with, all right? So the order of operations says that x minus h must be done first, then we must evaluate f, and then we need to evaluate a, and then k. So it must be in that order, okay, that we actually do our operations. Okay, so at this point, we have a quadratic equation, and so what we want to do is, since we have to graph g of x, we want to find what the some key points are. So let's go ahead and do the x-intercept first. Okay, I always start with the x-intercept. It doesn't really matter what you start with. All right. So in order to do the x-intercept, we're going to replace y with 0, and then isolate x. All right. So let's get, again, our goal is to get x all by itself. So let's, right now 2 is being added to it. So let's go ahead and subtract 2 from both sides. Okay, so to get rid of x squared, we're going to get the square root, both sides. And right there we know that we're not going to have any x-intercepts because we have a negative here, so we're going to have imaginary numbers here. So basically we have no x-intercepts. So that takes care of that. Let's work on our y-intercept. To find our y-intercept, we want to replace x with 0. Remember, we're working with g of x over here. So 0 plus 2 is 2. So our y-intercept is this point right here. Okay, so now let's find our vertex. And if you remember the vertex formulas, the first one is x equals minus b over 2a, and then y is going to be simply placing that back into the function. Okay, let's define a, b, and c for our quadratic. And again, we're working with the function g of x over here. So a is going to be 1. B is going to, we don't have a b, so we know b is 0. And c is going to be 2. Okay, so let's plug this into our vertex formula here. X is going to be minus b, which is 0, so there's no such thing. So we know right away that this is going to be 0. And then once we have our x value, let's plug that back right into our equation. So we know x is going to be 0. And so this is going to tell us that our vertex is going to be 0, 2. Okay? Y equals 2 here. So we know x is 0, y is 2, and so this is also our y-intercept, so we know right away that that is going to be also our vertex. So let's get a few more points, since we really only have one, which is our vertex and our y-intercept, which is 0 and 2. That's not very straight, but it'll work. Alright, so let's get a few more points. So let's plug in, how about 1? I like to just kind of go in order. It makes it a little bit easier. Alright, so let's plug that into our equation. So y equals 1 second power plus 2. So y is going to be 3. Alright, so let's plug in, how about 2? So 2 squared plus 2, so y is 4 plus 2, so y is going to be 6. Alright, how about, let's do a negative, how about negative 2? We'll go the other way. Get the other side of our parabola going here. Alright, so that gets us to 6. How about one more? How about, well, let's just do minus 1. So y is going to be 3. Alright, so let's go ahead and plot some of these points. Alright, so I've plotted these points over here. They're in, it's a little hard to see, they're in blue. Alright, so now I have to carefully go ahead and basically connect the dots here and draw my graph. Alright, that's as good as I can do freehand here on my little tablet. Okay, so the second half of our problem here, we need to transform this graph that we just drew, okay? This is the graph of g of x, alright? We need to transform this graph 6 units to the right and 7 units down, alright? So that right there is just going to be a translation. This shape is not going to change, okay? We're just going to move this shape 6 units to the right and 7 units down. Alright, now I've drawn the axes over here. Since we're going to be basically working mostly in the 4th quadrant, I have this graph moved up a little bit so we have a proper quadrant that we're going to be dealing with. Okay, I have on the screen about horizontal and vertical translation. Since that's what we're going to be dealing with in this particular problem, I just have our little cheat sheet here for us. And then again, this exact image is available in your instructor guidance for this week. All right, so our graph, we want to transform it 6 to the right and 7 down. All right, so really this is a translation because we're not changing the shape, we're just moving it. Okay, so this is going to be a translation. All right, so according to our instructions, to shift to the right, and we want to go 6 units to the right, h has to be less than 0. All right, so h is going to be -6 because we want to go 6 units to the right. So in order to go right, 6 has to be less than 0. All right, so let's go back to our instructions. And to go down, all right, it needs to be less than 0. All right, so in this image, k is going to be v. All right, so this one's using variable v. It doesn't really matter what you're using, but in this formula I have k. All right, so k needs to be less than 0 as well in order to go down. And so since we want to move 7, it has to be a -7. So we have our values. Let's go ahead and plug those back into the equation, and let's put the equation in this form here. Okay, so y equals x minus, and then we've said h is -6. All right, so -6 squared. We have a +2. Remember, we're doing g of x over here. +2, and then we have to add k, and then we said k was -7. All right, so let's go ahead and simplify this. So we have x, and then minus a -6 is saying +6. Okay, so basically you can just think about, just connect the minuses, right? And it tells you right there it's going to be a positive. That's just one way to think about it. All right, and then we have +2 and -7. So this is going to be a -5. Oops, that's a funky looking minus. There we go. -5. All right, so here is our equation rewritten to include our translations. All right, so this is one way to write your equation. So we have x squared plus 6x plus 6x plus 36 minus 5, which is x squared plus 12x plus 31. So either of these equations are correct. Okay, so again, these are this is g of x rewritten to include our translations. All right, so now let's go ahead and graph this translation. Okay, so let's find some key points for our graph. Let's start with the x-intercept. All right, so we have, let's rewrite our formula here. Okay, to get the x-intercept, replace y with 0. Again, our goal is to isolate x, so let's, right now 5 is being subtracted from it, so let's add 5 to both sides. And we have x minus 6 on this side. All right, to get rid of this, let's go ahead and do the square root of both sides. And whenever we do the square root, we've got to do a plus and minus over here. So this becomes x minus 6 on this side. This becomes plus or minus square root of 5. So then x equals plus 6. All right, so let's get our decimal approximation. Since we're going to be graphing, we actually need the approximation. This is the exact value, but we need a decimal approximation in order to graph this so we know exactly where the square root of 5 lies. So square root of 5 is 2.236, so 2.23. Okay, so let's do the first one. So let's do positive 2.23 plus 6, which is going to be 8.23, so around 8. And so let's do the other one. Minus 2.23 plus 6 is going to be 3.77. Okay, so these are our two x-intercepts, decimal approximations. Okay, so these are not equal signs. It's an approximation. All right? Anytime you use a decimal form of a radical, you need to use the approximation symbol. Okay, so those are our x-intercepts. Now let's find our y-intercept, and we can find our vertex, and then we'll go ahead and graph it. All right, y-intercept is going to be, replace x with 0, y is going to be 31. So our y-intercept is the point 0, 31. All right, now let's find our vertex. Okay, remember our vertex formula. So to find the x-coordinate, it's minus b over 2a. And then we simply plug that back into our function to find y. So let's go ahead and get our a, b, and c values. Now let's go ahead and put it in this form. Remember, this is the same thing as our x minus 6 squared minus 5. Okay, this is just the quadratic equation, which is going to be easier to find our vertex. All right, so a is 1, b is going to be minus 12, and c is 31. Let's plug that back into our formula here to find our x-coordinate of our vertex. So minus, and then b is minus 12. 2 times a is 1. So we have a positive 12 over 2. 12 divided by 2 is 6. So our x-coordinate is 6. Now let's go ahead and plug that back in and find our y-coordinate. Anywhere you see x, you're going to plug in 6. 36 minus 72 plus 31. 36 minus 72 is going to be minus 36. Minus 36 plus 31 is going to be minus 5. All right, so our vertex is 6 minus 5. All right, so now we have all of our key points. Let's go ahead and graph this translation. All right, there's our points. Let me see if I can draw those. All right, that's pretty good for freehand. All right, so this, as you can see, was shifted. Remember, it was over here in between our first and second quadrants, and we simply shifted it 6 to the right and 7 down. All right, so now this is where our graph lies, over here in the first and fourth quadrants. Okay. All right, so that is this particular part of the problem. Let's move on to our next. We've got two more, a couple of inverses it looks like. Okay, the first composition that we're going to do here is going to be the inverse of f of x. All right, so when you're dealing with invertible functions, all you need to do is interchange the coordinates in each of the ordered pairs. All right, so basically where you see x, you're going to switch it with y, and where you see y, you're going to switch it with x. All right, so let's work through the first example here so you can understand what I'm talking about. All right, so we're dealing with the inverse of f of x, so we're dealing with this one right here. So let's go ahead and rewrite that over here. All right, so we need to inverse, all right, this. So again, we're just going to replace, we're just going to switch the x's for the y's and the y's for the x's, all right? So let's go ahead and do that. So this, let's rewrite it just using y equals 5x minus 3. Okay, so now let's switch. So we're going to say x equals 5y minus 3. All right? Well, now we need to solve for y. All right, so let's go ahead and do that. Again, we need to isolate y. So right now, 3 is being subtracted from it. So let's go ahead and add 3 to both sides in order to get rid of that 3 on this side. All right, so now we want to divide by 5, because right now y isn't by itself yet. Okay, it's being multiplied by 5. So to undo multiplication, we divide. So divide both sides by 5. All right, so this is as far as we can go. It's simplified as it can be. So the inverse of f of x is y equals x plus 3 over 5. So we can rewrite that here. Inverse of f of x plus 3 over 5. All right, let's work through our next problem. Okay, this one's basically the same thing, except we're going to be dealing with h of x. We're going to do the inverse of h of x. So we're going to be dealing with this one over here. Let me go ahead and rewrite that over here. This is what we're going to be dealing with. All right, so let's go ahead and write this as an equation. 3 plus x over 7. All right, again, the first thing we do is we go ahead and interchange the coordinates. All right, so we're going to put x over here. 3 plus y is over 7. All right, now we need to isolate y. All right, right now it's all being divided by 7, so to undo division, we're going to multiply by 7 both sides. These factor out. All right, so y is still not by itself. 3 is being added to it, so let's subtract 3 from both sides. All right, so here is the inverse of h of x, and so let's go ahead and rewrite that. Equals 7x minus 3. And that concludes this video.